I'm getting a lesson in all things magnets. These are strong, Rick.
Yeah, those are strong magnets. Ceramic magnet. I brought all different types of magnets today. So a magnet can be different shapes, but they also can be made of different materials. This, Amber, is pretty cool. This is a natural magnet. It's called magnetite.
Magnetite.
Magnetite. You see there's other minerals in with it. But this is a neodymium. That's a hard word to say. Neodymium for me anyway. And go ahead and hold that and put it right here. Watch how it attracts to the magnet. That is...
and
it's stuck.
It's somewhat hard.
Now this is iron ore. So really what I want everybody to know is this one fact. Magnets are attracted to iron, okay? And other magnets, okay? So that's, you know, when I try to teach this to students, in fact, that's actually a 4th grade standard. Magnets attracted to iron and to other magnets. And so this guy should be really attracted to that. It is very attractive. But like I said, the Earth is a giant magnet, has a magnetic field, and because of that, we can use compasses. And compasses, now this is kind of weird. Where does a compass point?
North,
to the North Pole, right? So it points to the North Pole, but it's actually the north end. And we teach kids that opposites attract. So why does the north part of the needle attract? So if you want to be proper, it's the north attracting pole. But nobody's going to change north and south pole. It gets too confusing.
No, probably not, Rick.
No. But if you look at this, that points to the North Pole unless I bring another magnet nearby it.
Oh, look at that.
And so compasses work unless you're by another magnet, and that could be a problem. I wore this hat. We also use magnets in medicine, MRI, magnetic resonance imagery, and so this is really complicated, but they can very quickly change the atomic level inside of your cells and then get an image from it. Who knew? I mean,
it really is incredible.
Yeah, so the magnets, I'm going to put this guy here, and this...
So Rick told me, you guys earlier, if we can pan the camera over here, he told me, be careful of this magnet. You say this one, I don't even know, whoa, did you see that? Like how strong?
That is an H54. It's a neodymium. It really is somewhat dangerous.
Oh gosh, I don't even want to.
No, it's
because it was already shaking this one.
Yeah. So if you,
I'm gonna back up.
If you just even put this here close to it, and here.
Look how fast that.
Now this glass marble. What do you expect?
Well, I don't know. Do I even stand away?
Trust yourself. What are you going to do? The glass. What did I teach you at the beginning?
Oh no, Rick! Don't do this. Don't quiz me on the spot.
No quiz. This is made of iron. This is made of glass. So what do you think? No.
Okay.
Just for fun.
Because it only attracts iron and other magnets.
There you go. Boom.
I got that 4th grade lesson down.
Be careful. Put another one on there. That's the fun part. Now do me a favor. Take one of those off.
Oh my God.
And you are a strong person.
Hold on.
There you go. You don't want to get between that and iron, to tell you the truth. But okay, so
that's tough.
That is a cool magnet. I'm gonna put it over here. So way over here.
Wow.
So we have these invisible lines of magnetic force. And there was a scientist named Michael Faraday who actually, I went to England and saw his notebook where he drew those. So you can actually see them. In here, those are iron filings, okay, made of iron. And this is, believe it or not, a cow magnet. Cows have several stomachs, and you don't want cows back in the day eating baling wire. So if you put this in their stomach, yes, I know, it would attract that iron, and their digestive juices would cause the iron to disintegrate, but not go through their body. But I kind of like, it's a cow magnet. I know it sounds weird.
Wow.
But if you put it in here, you can see a 3-dimensional magnetic force. See it right there?
Yeah.
That is so cool.
Rick, it's amazing how much time we've already taken up. I've been so enamored with everything here, but you're sticking around. We're not done. Okay. You have something special coming up for us in part 2.
I think I'm going to try to use the Earth's magnetic force to levitate. Is it science or pseudoscience? Let's find out.
Just going to leave that right there, George.
Talk about levitating.
We're going to levitate.
Look at this, levitation.
Look at that. I'm skeptical.
Yeah, me too.
Well, the science is
Skeptical.
pseudoscience, but
I asked him if he's going to meditate while he levitates. You know,
so the Earth is this one giant magnetic field, and so maybe I had enough iron in my blood today that I can repel. Let's see here. I've got my giant magnet. I've got the Earth here. Let's see if I can try 1 foot. Does it look like it's doing anything?
No.
No, not yet.
Maybe I need to look at my reference book. Do we have a reference?
Yeah, well, you might want to try this here.
Oh, okay.
Yeah, that might help you out.
Fun with magnets. Okay,
Yeah.
a kid's book. That should.
Yeah.
That should
There you go.
Okay, let's
All
see.
right.
Let's concentrate here. So, if I come
Yeah,
back.
I mean, where's Pavel with our mood music?
Oh yeah.
Yeah, we need some music.
Let's see. So let's try 1 leg. Ooh, let's try 2 legs.
Oh!
And
What?
Are you straining?
I should relax more.
You should relax.
If I relax, maybe I can get higher.
Take a deep breath.
I tell you, harnessing the magnetic force of the Earth is not easy work. So a magnet attracts other magnets or iron. And I can't believe I'm doing this. This is,
When was the last time you did this?
well, about 5 years ago. My blood's been iron poor for a while.
And look at this mad scientist jacket you have on.
Yeah, that helps.
That is so cool.
I'm sure it does.
So whether you can levitate or not, it's always fun to learn about science, and especially magnets.
What do you think, Rand? Could you pull that off?
Oh, yeah. Let me wear that coat and I can pull it off. Right?
Oh, yeah. Oh, super cool, Rick.
Okay.
I love it.
I got to get back down to Earth
Okay,
somehow.
you good?
How long
Good?
can you stay up like that? As long as
The magnetic fields switch every million years
okay.
from north to south. So
it's shifting constantly, isn't it?
it's not exactly at the north. There's the magnetic north and the geographic north. But we look at mid-Atlantic ridges of magma to tell where it used to be.
Yeah.
It's kind of cool stuff, cool science. Or
Cool science.
pseudoscience.
Pseudoscience. Cool education.
Here,
Rick,
read the book while
thank
you're
you
doing
so
that.
much.
Yeah, thanks.
What do you think, Kayla?
That was amazing.